We're going to be covering a number of things in this video regarding polynomials. The first thing we're going to be covering is what is a degree? What does a degree of a monomial or a degree of a polynomial mean? Notice there's no essential question on this page. I didn't have room to put it in here for you. So if you want to write this, just start off with this upper left-hand corner, the degree of a monomial. The degree of a monomial is the sum of the exponents of all the variables. So you got to take a look at all the exponents of all the variables, and you're going to go ahead and add those up, and that's going to be the degree of the monomial. Now take a look at the first one. This is 4, and you can see there are no variables. So because of that, the degree of this particular monomial is 0. Oops, I don't want to draw in black. Let's try a purple. Okay, how about 7x? Well, I know you don't see an exponent, but remember, when a variable doesn't have an exponent, it really does. You just don't have to write it, and that's a 1. This is x to the first power, because x to the first power is just x. So in this case, the degree of this monomial is 1. Here's the next one, 2x squared. There's your exponent of 2. That means the degree is 2. In this case, we have a monomial with 2 variables. One of them has an exponent of 2, and the p has an exponent of 1. So 2 plus 1, and that means this monomial has a degree of 3. And let's take a look at the last one. You've got an exponent of 3, an exponent of 2, and then the z has an exponent of 1. So we've got 3 plus 2 plus 1. The degree of this monomial is actually 6. Okay, let's take a look at degrees of polynomials. This is done a little bit different. The degree of a polynomial, remember a polynomial has more than one term. The degree of a polynomial is the largest exponent, of the variable, whereas degree of a monomial is the sum of the exponents. So let's see how this works out. 2x minus 9. The x has an exponent of 1 on it. That's the largest exponent of any variable in this expression. That means the degree is 1. We actually call this linear. You saw this last year in Integrated Math 1. This is a linear equation. If you graph out, if you put y equals 2x minus 9 and you graph that, you'll get a straight line. How about the next one? We've got 3g squared plus 2g minus 4. The largest exponent, let's go ahead and circle these so you see them. There's a 1. Okay, there's a 2. The largest exponent is a 2. That means this has a degree of 2, or this is a second degree. This is actually called a quadratic. We're going to be doing a lot of work with quadratics in the next unit. Okay, the next one, negative 6t cubed plus 3t squared plus 1. The largest exponent is 3. That makes us a third degree polynomial. And we actually call this a cubic polynomial because it has a third degree. And then the last one, let's take a look. We've got 4k plus 3k to the fourth minus 12. It doesn't matter what the order of the terms are. This is the largest exponent in this polynomial. That means this has a degree of 4. This is a weird name. We actually call this quartic. Alright, you're not going to get any degrees higher than that probably in this class. So there is how we find the degree of a monomial and the degree of a polynomial. Let's take a look at our other questions that we're going to be answering on this page. Next section, classify each polynomial by its degree and the number of terms. So all you got to do is for each one of these expressions, write down what is the degree and what kind of a polynomial is it. Binomial, trinomial, monomial, what is it? Well, this one, let's go ahead and circle this. This is a binomial. Its highest exponent is 3. So this is a third degree binomial because it has 2 terms. Take a look at the next one. Well, we already know this is a trinomial because it has 3 terms. What's our highest exponent? Here it is. It's the 4. So it's a 4th degree. 4th degree trinomial. All right, how about this one? Well, I know this is a binomial. It's got 2 terms. That part's pretty easy. And let's see, our highest exponent is actually 1, because this is the exponent of the x term is 1. So this is a 1st degree. And remember, we just talked about how that's linear. It's going to be graphed as a line. All right, and the last one here, well, I can see it has 3 terms, so I know it's going to be a trinomial. And don't let the radical here, this square root, fool you. We're looking at our exponents. The 2 is still our highest exponent, a squared. So this is a 2nd degree trinomial. So that's how you classify a polynomial, by its degree and by the number of terms. All right, next section. Write each polynomial in standard form. Standard form. This is the first time you've probably seen this. Then circle the leading coefficient. Okay, standard form means this. You have to put the terms with the largest exponent first, and then you work your way all the way down, lower and lower and lower, until you finally get to something without a variable, which is a constant. So in this case, if we want to write this in standard form, we're going to take the x squared term and put it first. And then we're going to take the x to the first term right here and put it next. And then we're going to put the constant at the very end. Now I want you to be aware of something, class. The sign always stays with the term that's after it. So maybe for some of you, it'll be nice for you to put a plus there, because since there's no minus sign, that means it's a positive for x. Make sure you're aware that's a positive number. Then when you write it down, you know to put a positive number. And then the next part is circle the leading coefficient. When we say leading coefficient, that means it's the first coefficient in our polynomial, which in this case is a 5. All right, let's do one more. T plus 2t squared minus 8t cubed. Well, first of all, I want to make sure I put a plus here so I know that's a positive t. Our highest exponent is t cubed, and that means our first term is going to be minus 8t cubed. Our next term is squared. That's going to come next, so positive 2t squared. Now notice we have a, now we have a t to the first. That's going to come next. That's a positive t. And notice on this one, there's no constant, so we don't have to write it here. So again, notice we go highest exponent, then go lower, lower, all the way to constant. If there was no t squared here, you wouldn't have that as a term. You would skip it. So you don't have to write something down when it doesn't exist. Since there is a t squared, we would have it. But if this was just negative 8t cubed plus t, you just write negative 8t cubed plus t, and you would skip the squared term. Just make sure they go from highest exponent to lowest exponent. Okay, so now that we're in standard form, let's go ahead and circle the leading coefficient, which in this case is negative 8. And then the last part of this page, evaluate the following polynomials. So we just want to review what the word evaluate means. We've done this already. It just means take the value of the variable that you're given and plug it in to the expression or equation and solve that particular expression or equation. So 4t squared minus 7, evaluate that binomial when t equals 5. So all you do is you just rewrite the binomial, but every time you find a t, you just change it to 5. Now remember, class, always, always in parentheses. And why do we do that? Because it makes putting it in your calculator really easy. So I'm going to go ahead and move this over, and let's go ahead and plug this in. We've got 4, parenthesis, 5, close parenthesis. You're going to have a key on your calculator that has a x squared. Mine looks like an x with a hat or a upward pointing symbol with a 2. That means 5 squared. And now we're going to subtract 7. We press equal, and we've got 93. So our answer for this one is 93. Let's do one more. Negative 5x squared plus 14x plus 4. Evaluate that when x equals negative 3. Here's another reason why you'll see I use parentheses. Watch. It keeps all your negative signs in proper place. This is negative 5. We're going to plug in for the x, negative 3 in parentheses. Then plus 14 times x, which is negative 3, again in parentheses, and plus 4. Now watch how much time this saves you. Plus, it makes sure you don't mess up your minus signs. You let the calculator use PEMDAS to solve the problem. Let's go ahead and plug this in. I'm going to scroll this over a little bit so you can see this a little bit better. And watch how I plug this in. Because it starts off with a minus sign, you got to use the plus minus key. So minus 5, parenthesis, negative or minus 3. Again, you're not subtracting. That's why you have to use the plus or minus key. We're just telling the calculator it's a negative number. Close parenthesis, raise that to the second power, plus 14, parenthesis, negative 3. Again, it's not minus 3. It's the plus or minus sign. So we tell it it's a negative 3. And then you just add 4. So take a look at that. We've just put the whole expression in our calculator, press the equal sign, and you get negative 83. All the work was done by the calculator. Now some of you may like to do this by hand. Maybe you're good at it. No problem at all. I can do that. Let's just quickly show you that if you decided you just love to do everything by hand. This is negative 5. You don't have to write this in your book. This is negative 3 squared. Negative 3 times negative 3 is positive 9. 14 minus or times negative 3 is negative 42. I believe. Let's see. Yep. And then we've got plus 4. Then you'd multiply this out. This is negative 45 minus 42 plus 4. And then you do negative 45 minus 42 is negative 87 plus 4. And negative 87 plus 4 is negative 83. Now that is a lot of work when you could have just written it with proper parentheses the first time and then just use your calculator to do all the PEMDAS steps. So if you like to do it this way, the blue way, it's totally fine with me. You can use a lot of paper and a lot of pencil lead. I'd rather have you learn very well how to accurately put the equation or expression into your calculator and let it do the math for you. Alright, that is the end of this video.